Hi, dear students, how are you? Hope you're fine. Today we're going to talk about the indirect proof and inequalities in one triangle. So let's start. I have here a question before we start our lesson. If I ask you to write a conditional from the sentence an isosceles triangle has two congruent sides. So we have here this isosceles triangle that has two congruent sides, right? Then we have here, if I say that it's an isosceles triangle, therefore it has two congruent sides. Okay, guys, now we're going to have the contra positive of the conditional. If it's Tuesday, he asks me to write the contra positive of the condition. If it's Tuesday, then John has a piano lesson. So the opposite of that, if John doesn't have a piano lesson, so it's not Tuesday, right? Show the conjecture if x greater than 6. So 2x greater than 14 is false. So we're going to have, yes, an example here. And instead of x, we will put here, guys, 7. So 7, yes, it's greater than 6. But double seven, is it greater than 6 or not? It's 14. 14 greater than the same 14? No, so this is false. Okay, so let's start our lesson. Okay, guys, this is our new theorem, angle-side relationships. If we have here, if two sides of a triangle, are not congruent, then the larger angle is opposite to the longer side. What are you saying? Let's see. If I have here AB, can you see this one? This side is greater than what? AB is greater than BC. Yeah. So AB is facing, yes, is facing here, is opposite to the larger angle, Again, if we have here a longer side, so it's facing here the larger angle. So here angle C is greater than angle A, because AB is greater than BC. Okay? Okay. And we have here, what else? If I say here, if two angles of a triangle are not congruent, then the longer side is opposite to the larger angle. It's the opposite of this theorem. Okay? Okay, let's have here an example. He asks me here, write the angles in order from the smallest to the largest. Okay? So, what should we do? We look at here the sides of the triangle. So the shortest side here is 4GH is 17.2 and it's facing here opposite to angle F. So angle F here will be the smallest. He asks me to order from smallest to largest. This is the first here. Then comes what? Here comes side FG, it's 19.6 and it's facing here angle H. So comes after that angle H. Then angle what? Then angle, we have here 20.4 facing angle G. So here angle G. So F, then H, then G. Okay? We have here another example. Write the sides in order from the shortest to longest. Okay, so he gives me here two angles and one here other angle. The last angle is missing, so I'm going to add 60 plus 72, okay, and 180 minus the sum of them gives me 48, right? So the smallest here, I will write here the answer of angle R, it's 48 degrees. So we have here 48, 60, 72. So the least one, which is 48, it's here opposite to the, yeah, the shortest one, the shortest side. Then he asks me to order from shortest to greatest. Then which one? 60 opposite to QR, then QR comes the second, then QR here. Then I have we have here 70 is facing or opposite to PR, so PR comes the last one, the longest one. We have here this example. It's the same idea here. Write the angles in order from smallest to largest. So you're gonna see here from the smallest. So you're gonna here search for the shortest here segment and say B. Then it's here facing A. Then A. Then I have here facing to C. Okay, so it will be B, A, and then C. Very easy, I know. What about if he gives me this example and asks me to do the same order from the shortest to the longest? So I'm going here to identify or find measure of angle E. I have this is 90 degree. Okay guys, 90 and 22. So this will be 78. So I'm doing the same. We have here 90 degree, which is the greater here 90 degree. So 90 degree will face or will be opposite to the longest one. So the longest here is DE is the longest one. Okay, and then I have 68. 68 is facing, yes, FD. So here FD. Then I have here the last one, 22 is facing EF. So EF is the shortest here. EF, then FD, then DE. Another theorem that we have got here, guys, a triangle is formed by three segments. Okay, we know all of us know that, but not every set of three segments can form a triangle. Yeah, why? Let's see together. If I say here segments with lengths of 7 and 4 and 4 can form a triangle, guys, but segments with lengths of 7, 3 and 3 cannot form a triangle. Why? Because here the sum of 4 and 4 doesn't give me, yes, gives me here more than 7. 4 and 4 here, the two sides 4 and 4, 4 plus 4 is 8, and this is greater than 7. So this is considered a triangle. They can form a triangle, but we have here 3 and 3, the sum of them, 3 plus 3, the sum of them is 6, and 6 it's not greater than 7. So it doesn't give me a triangle, guys. So guys, remember this theorem is very interesting too. So if we have here in any triangle, the sum of the two lengths of a triangle is greater than the third side. So what are you saying? AB plus BC must be greater than the third here side AC. Okay, what about BC? BC plus CA or AC, the same, must be greater than AB. Okay, what about the next one here? We have AC plus AB must be greater than BC. Okay, so tell whether a triangle can have sides with the given length. Explain. The question will be like that exactly. Okay, so it's okay. It's okay. So we have here 7 and 10. Take the two sides here, 7 and 10, and add them. 7 plus 10 gives me 17, which is not greater than the third one, 19. So this one cannot give me a triangle. So no, by the triangle inequality theorem, the answer should be like this. The triangle cannot have these three sides. Okay, so he gives me another example here to whether a triangle can have three sides with the given length or not. Explain. We have here three sides with decimals, so we're going to take the sum of two of them and think. So it's greater than the other side or not. 2.3 plus 3.1, I chose here the first two plus each other. So it gives me 5.4, which is greater than 4.6. So it satisfies our theorem. What about here? I took 2.3 in the other one. I took 2.3 here and 4.6. So the sum of them is greater than the third one. What about if I took 3.1 plus 4.6? Also greater than 2.3, so it can be. Yes, the sum of each pair of the length is greater than the third length. Okay, we have here another theorem, and it's very another kind of questions needs some calculations here. So guys, concentrate in this one. Tell whether a triangle can have sides with the given length. Explain. The given length here are given by expressions, guys, and here it's given here the value of n. So substitute the first step, evaluate the expression, and it's very easy to evaluate expressions, guys. N plus 6, instead of n, write 4. 4 plus 6 is 10. And here n to the power 2 minus 1, instead of n, write 4 to the power 2 minus 1 gives me 15. 4 to the power 2 is 4 multiply, yes, 4 is 60 minus 1. What about this 3 multiply n? We have here hidden multiplication, so 3 multiply 4 equal 12. So we have here, guys, the three sides, and now I want to know 10 and 15, 10 and 12 is greater than 15 or not. Let's compare here the length. Okay, so I'm going to choose from each, okay, to combine here both sides together. 10 plus 15 is 25 greater than 12, right? Okay, then I took here 10 and 12, okay, 22 greater, and then I took what? I took here 12 and 15, so all of them gives me that satisfy the theorem, so they can form a triangle. Okay, we have here the same concept, okay, guys. So, okay, let's solve this example. It's example 4. Okay, so we have here the length of two sides of a triangle are 8 and 13. So we have here two sides, 8 and 13, guys. And the third side is missing. I don't know it. Find the range of possible length of the third side. So guys, remember, I have here 8 and 13, and the third one I don't know. Okay, and he asks me to find the range of possible length here of the third side. How can I do it? It's very easy. Let's hear the unknown will be x, as we usually do. Then I'm going to try. I'm going to use the inequality theorem. It's very easy, guys. So you have here x, and you have 8, and you have 13. The sum of two here sides must be greater than the third side. So let's here use x plus 8, the first one, greater than 13. X plus 8 greater than 13. Okay? And then I'll take x plus 13 greater than 8. I'm taking x plus 13 greater than 8. This one. And then 8 plus 13, 8 plus 13 greater than x. So I tried the three numbers or the three combinations here. After that, I have here x plus 8 greater than 13. Okay, guys, we take here the inequality. We took here the positive 8 go to the other side by negative 8. So x here equals, x is greater than what? 13 minus what? Minus 8. So x is greater than what? Greater than 5. So we have got here x greater than 5. What about this one? Let's clear. What about this one, guys? The second one, the second combination. X plus 13 greater than 8. So 13, positive 13 goes to the other side by negative sign. 8 minus 13 gives me what? Negative 5. Here I write negative 5. What about this one? I have here 13 plus 8 gives me 21, so 21 greater than x. So I have here the three of them. X here is greater than, as you see here, x is greater than 5. Here x, this one, x greater than what, guys? 5. And what? And x less than 21. x less than 21. So this is the, yes, this is the, here, the length of the third side. Okay, the length of the third side, okay, must be greater than 5, greater than 5, and less than 21. Okay, guys, we have here another example. The length of two sides of a triangle, this time 22 and 17. Find the range of the possible length of the third side. So guys, we have here, remember, 17 and 22, and the third one is missing, and we assume that it's x here, variable x. Remember, I'm going to have combination here between 17 plus 22 greater than 17 plus 22 greater than x this time, and x plus 17 greater than 22 this time, and here the third one, x plus 22 gives me a greater than 17. After doing so, remember, I have to, yes, solve the inequality. So positive 22 goes to the other side by negative 22. So x here greater than 17 minus 22, then x here greater than 17 minus 22, negative 5. Do the subtraction easily and take the sign of the greater one. So the answer, okay, it's negative 5. What about this one? The same idea here, guys, goes to the other side by, okay, so it goes with the other side by negative. So the answer here, positive 5. And then here, add them, 39. Okay, guys, this means what? This is the most important thing. X is greater than what? X is greater than what? X is greater than 5. X is greater than 5 and less than what? And less than 39. Less than 39. So this is the range here of the inequality, as you see. Thank you, dear students, for listening. I hope you understood. If you have any question, please send me on Google Classroom. Bye bye.